Hey guys, welcome to the video. It's time for Elasticsearch Essentials and how we can integrate it with .NET. This is the latest exclusive video lesson, so let's start. First, we need to cover what exactly is Elasticsearch, because Elasticsearch is very famous right now. It's super popular. A lot of developers are talking about it. It's a buzzword. So every time you hear someone says elastic, and people are going crazy because people think that that's super cool, it's super fast, it's super scalable, and most of the time this is quite true. So we have a lot of elastic things in the cloud, but the term started pretty much with this so-called Elasticsearch. This is the fundamental, and this is a database which is quite mature currently, and I have been using Elasticsearch for maybe 5 years now, maybe even more. A lot have changed since I started using Elasticsearch because they constantly evolve the product, they constantly change some things. There are a lot of breaking changes here and there. So if you start with the current version and if you see what I'm going to show you right now, and if you don't use Elasticsearch for, let's say, a year, you may um, find yourself that it changed a bit. So what I will try to do with this video is I will try to give you everything that you need to know around Elasticsearch, what's important, what are the best use cases, what are the fundamentals of Elasticsearch, and then if something changes, it will be a matter of quick research on Google to find what is different. So currently I'm going to show you Elasticsearch version 7, but for example, if you start using Elasticsearch 9 in the future, you may find yourself that you have a little bit of breaking changes here and there. But that's not important. If you understand the whole concept, what Elasticsearch is good for and what it does, then all of the other things are just details. So don't worry about that. But in my experience, it changes quite a bit here and there. So Elasticsearch pretty much is a popular NoSQL distributed database. So I guess that doesn't sound that's not explanatory enough. So I'm going to talk about each of these different terms so that you can understand better what Elasticsearch does for you. First of all, it's a document-based database. So it doesn't have a strict language. It has custom language built for Elasticsearch itself. It doesn't have any schema requirements. It doesn't have any tables. It doesn't have all of these classic SQL things that you may be used to. So pretty much with Elasticsearch, you can insert documents. You can insert whatever JSON document you feel like you need to insert in it, and you can retrieve it later super fastly. So what's the difference between Elasticsearch and, for example, MongoDB then? I'm going to cover that in a minute, but Elasticsearch is similar to MongoDB in terms of how you use it. You just run the database, you just install it or use a cloud, it doesn't matter. Then you just need to insert documents and you can search these documents. And that's pretty much it. So, of course, there are a lot of tiny little details that are important. We are going to cover them, but most importantly, it's not a SQL database. It doesn't have tables. It doesn't have any schema. Of course, you can specify a schema if you want to use it like this, but it's not required. Uh, The thing is that you don't have schema, you don't have any tables, and Elasticsearch doesn't use a popular query language. So the query language is custom and is for Elasticsearch. But that's pretty much true for every NoSQL database, every document-based database. What does it mean that it's distributed? This database is distributed because it's very easy for you to say that you want to have the database spread across multiple computers, multiple nodes. It's super easy. And if you decide to add additional node, Elasticsearch will move the information so that it will be equally distributed between all these computers. So it's automatically done for you. If you want to use multiple nodes, you can easily do that. It's very simple and it doesn't require a lot of settings. You can just specify I want to have this much settings and Elasticsearch will distribute it for you. Good. So about using Elasticsearch. First, why Elasticsearch? What's the difference and why it's better than other document-based databases? First, Elasticsearch works like an index. You can insert a lot of documents in it and all of these documents will be indexed and you have a super fast retrieval. So in terms of what Elasticsearch is good for, it's good for searching. Well, that's a little bit self-explanatory from the title of the product itself, but nevertheless, you have very fast search among millions of documents. So Elasticsearch is very good for indexing a lot of documents, a lot of text, and you can easily search through it. Um, The second thing that Elasticsearch is very good, it's very good for relevancy because Elasticsearch applies scoring to the searches. So for example, if you have a lot of text, let's say that you have the most simple example here, you have a blog. You have a blog with a lot of articles, with a lot of texts and quite a lot of information in it. Or, for example, you have a forum with thousands of texts, thousands of topics, thousands of answers, thousands of comments, a lot of text, a lot of text. And if you want to search, for example, let's say that you want to search for the word cat. Elasticsearch will find super fast, every single document that contains the word cat. But let's say that you want to search for the term, for example, cats and dogs. Elasticsearch will find you all the blog topics that have the word cat, all the blog topics that have the word dog, and all the blog topics which have both words, cats and dogs. And it will score these topics that have cats and dogs higher in the results. So depending on the search terms, you will find better and better topics based on these searches. So if you have multiple words in your search, Elasticsearch will help you score the documents it found. It's very convenient for such searches, for more difficult searches. For example, if you search for let's say boots, again Elasticsearch will find every single document in which you have the word boot. But if you search for boots and dresses, it will find both boots, it will find dresses, but it will find boots and dresses in the documents. So it will be very easy to score and to sort the results based on their relevancy. It's out of the box. It works like magic, you know. It's very convenient for advanced searches. And finally, you can use Elasticsearch for statistics because you can easily see different trends in the data. So, where to use Elasticsearch? Elasticsearch is good for specific scenarios, just like Redis. If you watched my video about Redis, you will know that Redis is super fast and super convenient for specific cases. It's the same for Elasticsearch. It's not a good idea to use Elasticsearch for general purpose database. It's not good for that, but you can use it for specific scenarios. For example, we used it in a form. We had a form with more than 20,000 threads, a lot of text, a lot of answers, a lot of communication, and we wanted to have a quick search throughout all that information, throughout all that text. And it was very easy to do that by using Elasticsearch. We just inserted in Elasticsearch all the form text, and we stored which form ID was for that text. And Elasticsearch, we did that for like 2 days, maybe. 2 days. We needed to port everything from the old database to Elasticsearch. Of course, we didn't insert everything. We just inserted the text and the ID of the thread. So we inserted everything, and the search of this form started working super fast. It was very easy to do, and it was super relevant in terms of results. So Elasticsearch is definitely not a general purpose database, but allows you to have super fast search among records, among texts. So if you have a lot of text and if you want to find things that uh, these texts may contain, then it's super convenient to use Elasticsearch. This is the main use case. You have a lot of text and you want to allow the users to search among the text. You can use Elasticsearch for log analytics because usually when you log information in your data, you have in your application, you have a lot of data. You have super a huge amount of records in terms of logging. So if you want to search fast in these log records, Elasticsearch may be very good product for you. And finally, you can use Elasticsearch for documents with a lot of different attributes with unpredictable schema. But usually, most commonly, Elasticsearch is used for fast text search and log analytics. Of course, you can use it as a NoSQL database, but there are more general purpose databases out there which will be more suitable, like MongoDB. Of course, it depends on the specific scenario, so there is no one solution fits all. But if you need super fast text search or log analytics, consider Elasticsearch. These are the top use cases. So logging and log analysis, I already specified that because usually with logging you have millions of records and it's very convenient to search among these millions of records. Elasticsearch is very useful for combining public data. If you have lots of data coming from different sources, it will be very easy to store them in Elasticsearch and then searching among them. So if you have lots of sources, you can store the data from these sources in the Elasticsearch index, and then when you need to search among this data, you can easily combine it because the search is super fast. You can use Elasticsearch for metrics. If you have lots of information around metrics and analytics, you can easily use Elasticsearch. Like I said, you can use it for full text search because it's super convenient and super fast to search with Elasticsearch. And finally, you can use it for data visualization with a plugin called Kibana. I'm going to show you Kibana for a bit. It's a tool which allows us to visualize the data in the Elasticsearch database. So you can use Kibana for visualization because it has a lot of good and very advanced metrics, data charts, and so on. So you may find it suitable for that. So let's start with the Elasticsearch concept, because we now know what Elasticsearch is, what it's useful for, but we're not quite sure what are the main concepts behind the database. And these things, these definitions here, are not going to change in the future. So this is the fundamental of Elasticsearch. This is the essential part of Elasticsearch. So for Elasticsearch, you have the following terms. You have documents, which are used instead of tables. All of these documents are schemaless. You can apply some mappings if you want. You can apply a schema, quotes, of course, but it's not required. So you can insert your documents the way you see fit. They can be different in terms of attributes and columns. All these documents are stored in the so-called indexes or indices. So you have the document which contains our data, and we store the documents in different indexes. For example, you may have an index for posts in a blog. You may have an index for not articles, comments, for example, which are linked to the posts. You may have an index for threads, which are part of some forum. You may have an index for answers. These answers are for the threads, and so on and so on. So you can group your data in different indexes. That's the thing. Each index stores different kind of data, so to speak. So it's up to you to group your data the way you see fit. You should group your data logically in different indexes. So if we have a blog, we can create an index for the posts and index for the comments, for example. If we have a student system, we may create an index for the courses, index for the users, index for the resources, for example, the video lectures, and so on and so on. So you can create different indexes. So these indexes are stored across multiple shards. What is a shard? A shard is logical separation of the data. So for example, let's say that you have 1 million records, documents. If you have 10 shards, Elasticsearch will structure your data. Here are 10 million records. Will structure your data in 10 logical groups, each consisting 100,000 records. So what's the purpose of this? The purpose of this is that if you separate your data initially in different shards, you can then easily tell Elasticsearch to move these shards to different computers, different servers. You can start your Elasticsearch instance on a single computer containing 10 shards, and that's completely okay. And if you want to multiply your computers, if you want to store Elasticsearch on multiple computers, you can just say, hey, I have 10 shards on a single server, on one server, but now I want to add second server. And Elasticsearch automatically will say, okay, I'm going to take 5 of the shards and I'm going to move them to the second server for you. And that happens automatically. You just need to provide a new Elasticsearch instance, and that's it. That's pretty much it. It's very easy and very convenient, and it's super fast. You can specify multiple servers, and you can specify one, and you can specify initially when you start your project. You can say, I want to have 10 shards just in case. And if you see that your Elasticsearch database is growing bigger and bigger, and you need to spread it among different computers, you can easily tell to Elasticsearch, hey, I know I used one computer and one server. Now I want to use 5 servers because the data is getting huge. And Elasticsearch is going to say, okay, no problems. I'm just going to get these 10 shards I already have on the single computer, and I'm going to move them to all the new servers. And this way I will have 2 shards on each server. So these logical chunks can be easily then transferred to another servers, and all of this is done automatically for you. So what you need to do is you need to just say, hey, I have 5 shards. Then you just need to say, hey, I have another server running Elasticsearch, move the shards to it. And it's very easy. And if you decide to scale down, if you have, for example, 2 servers, and then tell Elasticsearch that you no longer need 2 servers, you can easily move everything to one server, and Elasticsearch will say, okay, 10 shards, no, not a problem. So these shards are stored on one or more nodes. Consider a node to be a server, and all of these servers combined to a single cluster. So you have lots of servers. Each server contains shards. These shards contain indexes, and these indexes contain the documents. And each index can be stored on many shards. It depends on how you configure it. You can say, I want to have an index with 5 shards, and you want to have an index with 10 shards. You will see later when we initialize our server in the code that you can just say, I want 5 shards. It's super fast and super easy. How to install Elasticsearch? So installing Elasticsearch is done by downloading a zip file from the website. You can go to elasticsearch.com and you can download it easily. You can see the installation guide I provided here. You can of course use a container, it doesn't matter. Oof, that's broken for some reason. Yep, here it is. You can see how to install on different machines and so on. Of course, you can use the cloud version, it doesn't matter. So what you need to do is install Elasticsearch. What happens is that you have uh, 2 zip files. The first one is for Elasticsearch. I'm going to mention Kibana in a minute. But with Elasticsearch, you just extract it, and it contains everything you need to run it. What you need to do is you need to go to the binary folder, and in the binary folder, you just need to run elasticsearch.bat. That's for Windows, but if you are using some other system or operational system, it doesn't matter. It's pretty much the same thing. So I'm going to start that. It will take 30 seconds to 1 minute to start, but after you start it, you can then go to localhost 9200 and validate that Elasticsearch is up and running. What you can do is you can install, for example, on a Windows machine, Elasticsearch as a background service, and you can turn it from the services. It's not very difficult to do that. So you can go to the services and you can install it here. It doesn't matter actually. So what you need to do, before running the Elasticsearch, you can go to elasticsearch.yaml in the config folder if you like. So if you go to elasticsearch.yaml, and you can edit all the settings here. There are a lot of explanations for each settings. It's all of the settings are running in default mode, but pretty much you can specify the cluster name and the node name. These, most probably these are going to be commented when you run them, but you can easily uncomment them and specify the cluster name and the node name. And it is important if you want to run a second instance of Elasticsearch, for example, on another port, on another network, and so on another host, and so on. You can specify that you have the same cluster and the nodes can be different, but that's more advanced and it depends on your scenario, so we're not going to cover it, but all the configurations are pretty much here. So if you configure Elasticsearch and specify your cluster name, usually there is a default cluster name and default node name, but nevertheless. So good. If Elasticsearch is up and running, we can go to localhost 9200 and we can see that Elasticsearch should be up and running. We have a good response, for search. Good. So Elasticsearch is up and running, and now you can send requests to it. You can do that through Postman, you can do that from your .NET client. If Elasticsearch is up and running like we saw, we can start using it. But before we start using it, it's a good idea to actually have a good web-based dashboard to use for Elasticsearch, because currently we only have the server running, the database running, but it's a bit more difficult to take a look on what's going on inside. So Elasticsearch has a very rich plugins ecosystem, so most probably if you need something, it will be already implemented as a plugin. One such plugin is the so-called Kibana. Kibana, you can download it from this URL, and it gives you web-based overview and access to the database because you don't have any UI. You don't have any graphic user interface by default. So after installation, it's pretty much the same thing. You just need to download Kibana. Here it is, and you can go to Bind and running Kibana on a separate terminal. As you can see, I have the first terminal and here is the second terminal, and I'm going to start Kibana too. It will take a minute or two, but after the installation you can go to localhost 5601, which is the default Kibana homepage. But if you want to run actual requests against the Elasticsearch database, you can go to /app/devtools. You can navigate to it. Of course, you can use a Docker image if you want to use containers. I'm currently showing how to use Elasticsearch. Locally. Well, it will take a while, so let's just continue with the lecture and I'm going to show it in a minute. So we have data types and index options next. What are the different data types and what are the different index options? What we can do with Elasticsearch? Well, instead of creating a typical SQL database, this is a typical SQL database. Create database, my block, blah, blah, blah. Create table, if node exists, post. This is the ID, this is the user ID, post tag, post date, and so on. Instead of doing this thing, instead of having a query language, you just need to create a post request or a put request to against the Elasticsearch URL, and that's pretty much it. Here is the same thing translated to the Elasticsearch language in terms of for the version 7 of Elasticsearch. So instead of create database, we just say I want to put on Elasticsearch my blog index. My block index, I want to have these mappings and these properties. Consider the properties to be like columns. Like I said, Elasticsearch is schemaless, so this is not required, but it's a good idea to have some mappings for your data. Of course, if your data is structured. If it's not structured, then you don't have to provide any specific things. But having these mappings helps Elasticsearch index things. So if you provide the mappings, it will be better. So the same thing is specifying user ID, post text and post date. We can just say the type is integer, the type is text, and the type is date. It's very easy and it's very convenient. Of course, each these properties have have many more options, but most probably you won't need them unless you need something specifically. For example, the date, you can specify format. You can specify format and say I want the format of the date to be something like this. Only the month and the year with 2 digits, something like this. And Elasticsearch will store the data like that. Good. So this is how you create an index. It's very easy and very convenient. Let me see whether Kibana started. Yep, don't worry about the warnings. Currently Kibana doesn't have anything in terms of security, but you can easily add some, you can easily enable security and you can easily add admin privileges, but it's not that important. You can go to the home page of Kibana. You have some data here you can analyze, you can add different visualizations and so on. But what is the most useful things in terms of Kibana if you don't want to visualize anything is that it gives you dev tools against the database. I have prepared some requests here in the dev tools, but you can write what you want. You can write whatever fits your needs. But it's very easy to create a request in the dev tools. You just need to write the request. Eventually you may need to specify the body, but if you write the request and just run it from here, Elasticsearch will return an error. Currently I'm trying to delete the index my blog, but I'm receiving an error that such index is not found. Yeah, because currently Elasticsearch doesn't have anything in terms of my blog. For example, this request get /_cat, this comes from catalog, /indices is a command which allows us to see all the different indexes in Elasticsearch, and we can see that we have some indexes. Some of them are from my testing, some of them are from Kibana, some of them are again from my testing, but yeah, you will have less indexes here. It doesn't matter. But we can see that the my blog index does not exist yet. We are going to add it in a minute. So let me explain the terms behind this thing here. So we have first the index. We need to specify my blog in the URL. We want to create an index. Then instead of the schema, we define mappings. These are not required, like I specified. These mappings are easier for Elasticsearch if you provide them. If you know them initially, it will be easier for Elasticsearch, but it's not required. And we have a type. Type is instead of a table, we define the schema. For example, currently our type is apparently post. We don't specify it anywhere, but we have the post. And finally, we have properties. These properties are just like the columns in a typical database, attributes that our type contains. If we have a post, we have user ID, who is the author of the post. We may have the text in the article, we may have the publication date, and so on. So each property has a different type: integer, text, boolean, whatever. And we can see that there is no ID field, because the ID field is generated automatically. We can override that, I'm going to show it, but it's pretty much generated automatically. What are the most commonly used commands? Well, I already showed you how we can get all the indexes. Get underscore cat dash indices. That's very convenient and very easy. Let's create an index. So to create an index, I'll need this. I'll need to say put index name my block. I want to have mappings with properties, and I'm going to specify I want post text, which is of type text, and nothing more. I'm not going to create all of the properties for now. So let's run that, and we can see that Elasticsearch returned acknowledged true. So everything is created right now. And if we go to get catalog indices again, we will see that we have the my block index ready for some documents. So to see an index schema, you can do get index underscore mapping. So if I run get my block mapping, I have it here, we can see that the mapping of my block is just exactly we provided earlier. How to insert a document? It's very easy to insert a document. If you want to have automatic ID, you just need to say post index underscore doc, insert a document, and provide the data we want to add. If you want to have a custom ID system, you can specify it by adding a slash here and specifying a number, for example 3, or for example some text, whatever your actual ID system is. So if you want to insert that, here it is. Let me remove. We can see that we have a successful insert. Here it is. The result is created. If we specify something like put my block doc1 and specify something else, we will see updated and so on, but it doesn't matter. So Elasticsearch returns the result, whether it's created, updated, deleted, and so on. Good. If then I decide to run hello from CodeItUp with custom ID, I can run this command, and I will see that we have another successful result added. So adding documents, it's super easy. We just need to send a post with index name slash underscore doc, and we provide the date. We can override the default ID system. How to search? The basic search for documents, and we are going to cover querying in a minute, but the basic search for documents is done by the myblock underscore search. You can get a specific document, give me myblock underscore document ID of the document, and you can get a specific search within a attribute, within a property. So let's try all these three. First, let's try the search command. The search command, here it is. You can easily search everything. And we see that we have two hits. You have hello from CodeItUp and hello from CodeItUp with custom ID. We can see that the ID here is some random GUID, and the ID here is 2, like we specified it. We can easily say, give me the doc with index 2, and we can see that the document with ID2 is hello from Coded Up with a custom ID. So it's very easy to search for documents by ID, to search for everything, and you can provide a simple query. There are more advanced querying options, but we're going to cover them in a minute. A simple query is just say, I want to search post text as awesome, for example. So let's try to search it like this. And we can see that we have 0 hits, no hits because the word awesome does not exist. But if we specify, for example, code, we can see that Elasticsearch found this and this. And we can see that the scoring is almost quite the same. Here it is. Elasticsearch provides a scoring system. And why this string have a higher score than this string here is because the word code from 1, 2, 3, 4, 5 5 words here is taking quite larger part of the whole sentence. You can see that we have 0.2, which is exactly like the number of words divided by exactly like all the words divided by the number of words. So we can see that this is 1/5 of the sentence. So this is why 1/5 is equals 0.2. Of course, there are some other symbols here, so this is why it's not exactly 0.2, but you get the idea. And we can see that because we have more words here with custom ID, the word code is less important. This is why the scoring is lesser. So most probably here the word code will be more important than here because we have more words here. This is why Elasticsearch gives such scoring. Of course, we may not care about the scoring. As you can see, Elasticsearch gives us all results, so it doesn't matter. But if we care about scoring, we can sort the results by this score. And if I provide, for example, custom, we can see that we have only this thing here with custom ID. And because it's only a single hit, the scoring is quite higher. Here it is for the word up. As you can see, it's case insensitive and so on. And Elasticsearch gives us the max score between the results, so we can easily find everything what we need. But it's a very cool system, the scoring system. What are the most important data types we need to know? Well, first we have text. It's the most common type, like varchar in SQL. You use it to store any collection of characters. We have booleans, true or false. We have numbers, the typical Java numbers, float, double, short, long, integer, and so on. We have dates, which are stored in UTC by default, and we may have binary format, which are images or blob data, which are stored in base64 strings. These are not indexed by default because it's very difficult to index blob and binary data, so it's not indexed by default. You may provide a custom index, but you need to be sure that the data of the binary files is actually structured in a way. Good. What you can also do is you can provide settings. For example, you can provide something like put my cool blog, and besides mappings, you can provide settings, which are something like number of shards, and you can specify, for example, 1, 5, 6, and so on. So you can specify the number of shards you want to use with this index. As you can see, it's very easy to set up the number of shards. And if you provide 10, for example, Elasticsearch will store this index in 10 different shards. And later, if you decide to add a second server, Elasticsearch automatically will take 5 of these shards and move them to the second server automatically. So it's very easy. And if you expect huge amounts of data, it's a good idea to just specify a bigger number of shards here initially. Of course, you can easily increase the number of shards, but it will take some time for Elasticsearch to re-index the data. So it depends on the data, but you may decide to start with more than one shard initially. What is the default data storage? Well, defaultly, Elasticsearch has two data storages, so to speak. You have the data you insert in Elasticsearch, which are the documents, and you have index. The index is fast retrieval of and are used for fast searching of these documents. So to speak, Elasticsearch stores your data in two places. First as a storage and second as an index. So when you decide to add a document, it's stored on two places, as an index and in the so-called storage. But the typical data storage is that you usually have a separate database. For example, in the .NET world, most probably we will have SQL Server as our general purpose database, and we want part of the data to be indexed in the Elasticsearch data store. So we don't want to store everything in Elasticsearch. We usually have another database. It may be SQL Server, it may be MySQL, it may be CouchDB, it may be MongoDB, and so on. We want to have our general purpose database, and we want to have some of the data in the Elasticsearch index. That's the important part here. So we don't want to store everything in Elasticsearch. We want to store only the data that is searchable and which can give us a back reference to the original storage. So for example, if you want to index articles, you will store the text of the articles here in the Elasticsearch besides the typical database here, so that you can easily search in the text, and you will store the post ID, which will be a reference to the original database. So if our article has author, if it has text, content, images, a lot of information, but you want to search only in the text, you will store in Elasticsearch just the text and the original post ID, which is a back reference to the other database. How to index data without storing it? Well, it's very easy to specify something like in the mappings, you can add a source attribute and specify I don't want to store the data, I just want to index it. And then if you want to store specific columns, you can add store true. So if you have a general purpose database like SQL Server, you can easily specify, well, I don't need to store anything in Elasticsearch, so please disable the storage, the default storage, and just index everything. I don't need anything else. And that's pretty much it. You will save. I'm not saying that this is the best practice. It depends on whether you want to store the data in Elasticsearch or you want to just index it. It depends on the situation. Sometimes you don't want to store the data in the general purpose database. It's completely fine. What I'm saying here is that you don't need to store the data in Elasticsearch if you already have it. If you already store it in another database, you don't need to store it here because you're going to use more hard disks. You're going to use more disk space, and you can save that. Next thing that is important, it's important to have something like routing. If you have multiple nodes with multiple shards, as you can see, each server here has multiple shards. Node 1, node 2, node 3, each of them has 3 shards. If you want to query something, you can, when you hit a request, Elasticsearch needs to provide to check every single shard for that query. So it's not that efficient. Of course, that's super fast, don't get me wrong. But if you want to optimize further, you can specify a routing. Routing uh, is an extra option you can use to query your data. By default, if you use sharding, Elasticsearch will separate the documents by their ID, their original ID. You can override that to optimize the performance of future queries. You may tell Elasticsearch to store the data for a single user in a single shard if you constantly search for data coming from a single user. So this way all the queries for the specific user will be as fast as possible because it will be on a single shard. So if you want to just know that if you want to optimize Elasticsearch even further, you can turn on routing. It's not required by default, and I'm not saying that you need to do it for every single Elasticsearch instance, no. But it's an option that you need to be aware of if you decide to optimize Elasticsearch even further, if you're not happy with the default performance. But of course, I'm saying that it's advanced feature, but it's worth knowing about it because someday you may start using Elasticsearch and you may say something like, well, Ivo told me that Elasticsearch is super fast, but I can see that it's not that fast, it's not that great. Well, if you come to this scenario, then you may consider enabling routing. Let's talk about querying and analysis a bit. So Elasticsearch has its own domain-specific language. Like I said, querying Elasticsearch is completely custom. It's not SQL, it's not the same like in MongoDB, for example, so it's completely custom. And results are returned sorted by score, like I said. So you have the domain-specific language which scores the results. So instead of writing this simple query that we saw earlier, you can rewrite that to have a more advanced query. You can say, I want to get my block, I want to search on my block, and the query details are query, please match post text to have the name cat here. So if I want to write it, I can easily specify something like, let me copy paste it because I have a more advanced query here, but I can say, okay, let's search for code. And if I hit it, we can see that it does the same thing like this one here. But this is more advanced query syntax because it allows a lot more options. The options are quite a lot actually, so I don't think it's necessary to cover everything. I'm going to give you only the most important parts of the DSL, but if you want to dive in deeper, you can easily read in the documentation. So you can, for the most essential and uh, most common scenarios, these are pretty much enough. But if you want something else, you may take a look at the documentation. But these are completely enough for the common scenarios. So you have much searches for at least one word in the phrase. So if you search cute cats, will match cats are cool. So let's go here, and if we say I want to search for custom code, something like this, we can see that we still get the two results, even though we're searching for custom code, we received the result hello from coded up with custom ID, and we received the hello from coded up. And this is because the match operator by default, the match operator search for any of the words. So we have custom and code here, and we have only code here. So both are included in the results. But we can see that the scoring here is quite higher because this result matches two of the words, and this result matches only a single one, only one. So we can see that apparently this hit is way more relevant for what we search for. And if we say custom code up, we can see that we have the same thing. And again, we have better score here because we have custom up and code here, and here we have code and up only. But if we remove custom, we will see that both of these will have similar scores. Like I said, this one has less words, so in terms of Elasticsearch scoring, these words are way more important in this sentence than here. This is why the scoring is a little bit less. You have match phrase. Match phrase will match the exact sequence of words. So this match phrase will have more predictable results. So if I search for cute cats, this will not match cats are cool. So depending on your business scenario, you may decide to use match or match phrase. So if I go here and choose match phrase, you can see that the Kibana editor gives me Intellisense. So if I want to write something, I have Intellisense, which is super nice. You can see that Intellisense is pretty much existing here. Okay, so if I hit match phrase, you can see that code up is does not exist. So let's run coded, but coded exists. And coded up with, if I write coded up with and run against that, we can see that only a single hit is now part of the results. So match and match phrase are similar, but are for different scenarios. It depends on whether you want to have a more loose search or more concrete search. You can use highlight, which will return a highlighted HTML with emphasized matches. You can use that HTML in your app directly, and you have AGs, which are actually powerful aggregations. These aggregations allow you to something's wrong with these links. These aggregations allow you to give and do different things. For example, give me the average result, the maximum result, search by range. You have a lot different operations you can do. I'm going to show you, for example, the range operator, but in a minute. So with aggregations, you can easily find, let me just edit this link because most probably, okay, so the link is completely fine. I'm just copying it wrong. If you click it, it will be fine. So yeah, aggregations allow you to aggregate your data, and they are quite powerful. So if you need something from aggregations, you can do it. You have filters. Sorry, range is not from aggregations, range is from filters. But with aggregations, you have things like give me the minimum, give me the maximum among the entries, give me the average calculation among the entries, and so on and so on. And with the filters give you an option to filter the data by additional operations. For example, you can say something like, I want to have a query which matches which has multiple which has multiple conditions. So this bool means that I will need to provide multiple conditions that all of them need to match. And I say this query must match post text cat, and the filter is I want to add additional filter, and I want to have range filter giving post date greater than or equal than this date. So adding additional filters is done through the Boolean operator. You can see that the domain-specific language is quite advanced. You have a lot of options here. You have filters, you have multiple conditions, you have queries, and so on. So considering the fact that these these uh, these languages change, and I've seen it change throughout the years, I don't want to give a lot of details around the language because it's not that important. You can see that in the documentation. I just want to provide you the most important concepts so that you can understand what to research for. So you can see that the query language is quite advanced. You can do a lot of things with it. How Elasticsearch analyzes text. So Elasticsearch tokenizes each string and stores it in which document it appears. So it used the so-called analyzers to convert these strings to tokens. What is tokenizing? Well, tokenizing is, for example, if you have coded up, this is the text, Elasticsearch will separate based on some rules different tokens, and it will allow you to search based on these tokens. So these three tokens will be created: code, it, and up. And if you, for example, have an exclamation mark here, this will not be a token because it's not that searchable, it's not that important. So depending on the analyzers, Elasticsearch will tokenize the data. So it has different kind of analyzers built in. For example, the standard analyzer is general purpose, which is the default one. You have white space analyzer, which breaks up by white space only. So this is useful for computer code because if you use standard analyzer, it will remove things like, for example, HTML tags. These will be removed. And if you want to break only by white space, you may want to be able to search by the tag itself. So the standard analyzer will pretty much return only words. White space is a little bit more advanced because it will contain all the symbols. So if symbols in your texts are important, you should use the white space analyzer. But if only the words are important in your text, you should use the standard analyzer. It's very easy to change the analyzer for an index. You have a simple analyzer which breaks up by everything that is not a number, and you have an option to unanalyzed. So the text will be inserted as is. Each analyzer converts the string by following this algorithm. First you have character filter, then you have tokenizers, and finally you have token filters. So for the standard analyzer, the character filter will remove HTML, it may convert the number 1 to the text 1, and so on and so on. So it will remove unnecessary characters and convert them. Then we have a tokenizer. Breaks the text by white space, period, comma, or whatever it's in the analyzer. And finally, we have a token filter. The token filter will remove different words which are not that relevant. For example, words like and or the. This is the important thing because most probably we want to search for specific words and not generally used words like and the. So this is why this general purpose analyzer removes them. You can write your own analyzer if you want, that's also an option, or just install an analyzer from the internet. Now let's see how to work with Elasticsearch from a .NET client. Here it is a very simple application that just contains the basic settings to start working with Elasticsearch, and you will see that once you know the essentials, once you know the concepts, it's very easy to work with Elasticsearch. Of course, for advanced queries, you need to take a look at the DSL, but what's important here is that it's not super difficult to use Elasticsearch. So what we need to do is we need an URI where our node is located. Currently we have a single node located on this URI, localhost 9200. We need to have connection settings, and we need to have an Elastic client which will connect with these settings. So that's pretty straightforward. You say, I want a node on this URI, I want to connect here, and you can provide even more nodes. If you have multiple nodes, you can provide them here, but currently we have a single one. So we connect to this URI and we use the default index my blog. So let me just check whether we need to delete my blog. Let's delete it. Yep, done. Good. So the client just received the connection settings. Then what we have is we want to create an index. Creating an index is very simple. We just need to have index settings. You can see that we can specify number of replicas and number of shards. So both of these defaults are 1. Replica, so replica means how much clones we want to have on the index. And shards means that the index is split between these shards. So if, for example, we want to put Elasticsearch in front of a load balancer, you may need to have multiple replicas, for example. But usually one is good enough. It depends on the scenario, of course. So how to create an index? Well, client.indices creates the name of the index, and then we provide the index settings. These are the settings, and we say we want to map the post object automatically. You can map it by providing different settings here, but most of the time you have everything automatically run for you. So here it is. We have a public class post with some user ID, post date, and post text. Super simple. Then that's creating of the index. And what we need to do is we need to insert some data. Inserting data is very simple. We create the data, for example, blog post from the past, and blog post from the future. And then we can call index document or index document async. It depends whether we want to use a sync await. And that's pretty much it. So if I run that, I will see that the data was inserted. We can check whether first we want to check whether we have a my blog index. Yes, we have 3 entries, and we can try to search and see what's in the index. And we can see that we have different user IDs, we have different blog posts with the different dates. Everything looks fine. So I'm going to comment the inserting of data, and I'm going to show you how to perform queries. So first is search for a blog phrase. Here it is, query for some term, search for blog. We have, here it is, it's very simple. Our result is client, give me a search, and you can see that the code here is pretty much the same as the DSL. Here it is. If I want to make a search with a query, I can say search a query with a match or match phrase on post text with this text. So we can see that we can specify client search on this entity, make a query with match, for example. You know, term is a simple way to make a match. You see that you can do match phrase like this. This is just a simple syntax. It's a little bit simpler than the normal match or match phrase. Here it is the match and here it is the match phrase. But it's pretty much the same as the DSL. And then I just say result.documents. You have hits if you want to analyze the scores, if you want to analyze the different results from the here they are, IDs, scores, index type, the different additional data. But if you want to get only the documents and the data, you can just say give me the documents, and you can see that we're searching for post text here. We are just printing the post text from the result. Perform match phrase is the same thing but more advanced query, because we need to say, just like in the DSL, search, the query is this, we want the match phrase on this field, and the query of the match phrase is past blog post. And finally, I have a filter. The filter, you can see that it's again exactly the same, translated from the DSL to the C# methods. We can see that we have query with bool, with must, with match, and filter with range with post date greater than. We can see the same thing. We search with query, bool, must match on field, this query, and we want to filter date range on this field post date greater than date time now. You have a simple range, you have date range. You can see that you have a lot of options here. You can find a lot of different things. You can tweak your queries, but these are the most essential queries we need to do when we want to do a full text search. Of course, a lot of other options exist, but like I said, these are more to read in the documentation. It's not part of the main concept of Elasticsearch, so it will be more like telling you what is already written in the documentation. So I want all my videos to contain the concept of the things and why you should use it and when you should use it. The main fundamental knowledge. From there on, reading on documentation is quite easy. If you understand what Elasticsearch exactly is, what it does and how to use it, everything else is just additional fast search, depending on the business case. Because if I want to show you everything that is the query API here, that will take like hours and you will most probably forget most of the information. So to keep it simple, I just want to explain the concepts. So running all these queries will just return the results. We can see that when we search for blog, we receive all the results, and you can see that this blog is first because it has higher score. Because like I said already, it has less words, so the word blog should be more important in this sentence than in this sentence. We can see that we have, this is a blog post from the future, which was here, blog post from the future, because we search for blog, but not only for blog, we search for blog posts which have greater than datetime now post date. This is why we receive only a blog post from the future. And match query results are empty because we don't have a past blog post here. You can see that this is a blog post from the past. So if I search for blog post from the past, it will return a result because we use a match phrase, and we know that match phrase matches the exact phrase, and you can see that now the phrase is done. And if we want to just say past blog post, but we don't care of the order of the wordings, we can see that the match will find block from the past as first, but it will find also the other because they also have blog posts. So in terms of scoring, this is the best because it contains the word past too, but because we are using much, it will search for past, for block, and for post. It doesn't care whether it contains everything. So much phrase will be more strict about that. Okay, and that's how we incorporate Elasticsearch in the .NET world, and that's pretty much it. So I explained to you the essential of Elasticsearch, what's important about it, what it's useful for, and how to use it. From here on, everything is just uh, additional reading depending on your business case. So guys, I hope you liked this lesson because I believe it explains everything you need to know for Elasticsearch if you never heard of it. And if you have any questions, you can shoot me a message or write it down in the comments down below as you wish. Thank you for being with me and bye for now.